dear viewers. You are welcome to Homeschool program. This is a program that has been running since the time of the quarantine. So we have been teaching you, I've been teaching our students and all other students in Uganda, in other countries that are following us. You know, this quarantine is not only here in Uganda, it is everywhere. So we are all in the same situation, but we are so grateful that our dear pastors, Pastor Jackson Senyonga and Pastor Eve Senyonga, they allowed our students to continue learning even when they are still at home. Okay? So please take this opportunity, use it and embrace it very well because it is for your own benefit. I would like to emphasize a few things before we start our today's lesson. On our slide 5, we can see a number of things that I want the students to first pay attention to before we start the lesson. I want you to be with a pen, I want you to be with a notebook, I want you to be with a pencil, I want you to be with a functioning calculator. This is chemistry. More so we are dealing with more concept, and this topic is all about determining or counting the number of particles. So to do this, we have to be with the calculator. Also, make sure you log in and you'll be able to access these slides. They are there on the internet. On our website, it is www.kodaischool.ac.ug. Please go to that website and be able to access the slides. When you go there, you find there very many topics. It is not only this topic that we are covering. All topics are there, all subjects are there. For those ones who are saying that every day we are studying chemistry, not every day. We shall be changing the subjects. This week and last week we have been taking you through chemistry, but the coming weeks we shall be handling different subjects. Okay? Different people will be coming to take you through different subjects. So please stay on the TV every morning. The lessons will be going on. Also, I would like to request you to invite the person who is still sleeping to come and attend with you the lesson. Okay? Also, I can invite parents to make sure they monitor their children to see where they are learning. Okay? And please, they should give you the accountability at the end. If we look at what we covered yesterday, we covered a number of things. We looked at the subtopic, which was ideal gas laws. We looked at ideal gas laws, and we were able to describe a number of things in this topic. If we go to that slide, you can see we end up summing up all the two laws. We looked at the first law, that was the Boyle's law. We looked at the Boyle's law. We described it as, we said this one states that when a volume of a given mass of a gas is inversely, says that the volume of a given mass of a gas is inversely proportional to its pressure. We said volume is inversely proportional to pressure at constant temperature. In this law, we say that the volume is inversely proportional to pressure. Volume, we were able to remove the proportionality sign and we introduced the equal sign, and we said there we get a constant K, sec over P. Then we multiply P both sides, we had to get Vp equaling to a constant. Okay? That we may say that is K. Okay? That's what we were able to look at. Vp is the same as PV. Please don't be confused. 2 times 3 is the same as 3 times 2. So this one is the same. Also, we were able to look at what they call Charles' law. And we said this one, in this one, you bring the volume, you say the volume of a given mass of a gas is, we said here it is directly proportional to absolute temperature. And we said in this one, the pressure is constant. At constant pressure. Okay? Looked at all this. Then here when we introduce the equal sign, we say constant times T. When we bring T this side, we get V over T equaling to a constant. We did all this one. This one, we were able to get what they call ideal gas equation. And we said the ideal gas equation is a combination of the two. If this one is saying volume is directly proportional to pressure, this one is saying volume is directly proportional to temperature, then we can combine the two and say volume is, okay, is directly proportional to temperature and inversely proportional to pressure. Okay? We can combine the two and say volume is directly proportional to temperature, absolute temperature, and inversely proportional to absolute pressure. So if we begin with this one and we want to remove the equal sign, what do? We say V will equal to a constant, okay, times T over P. We were able to make the word constant be the subject of the formula, okay? We are able to make the word constant to be the subject of the formula. And we said that we have to multiply P this side and we divide T this side. And we are able to get V. Okay, let us begin with what you want. PV over T is equal to a constant. That's what we are able to get. We are trying to get the ideal gas equation. Okay? To get it, we use Boyle's equation, Boyle's law, and Charles' law. We combine the two and we get the ideal gas equation. We said here, if we alternate, if we make sure that this one, if P is 1, V is 1, and T is 1, we shall get 1. But if we change, okay, if we change from what is here, we are saying if we change, we shall also get the same constant. If we say this is 2, that one is 2, this one is going to be 4. Why? Because of this law. V is directly proportional to T. Okay? But V is inversely proportional to P. That means here, we are going to, if we increase P because of this one, if we increase P, we are going to decrease V because they are indirectly proportional. But if we increase V, we have to increase T because these ones are directly proportional. And C, we shall get a constant. Then we end up saying P1, V1 over T1 can be equal to P2, V2 over T2. That's what we got at the end. And we said that one is what we term to be the ideal gas equation. And here, we said if you are given, there are how many constants? 1, 2, 3, 4, 5, 6. If you are given 5 of them and you are asked to find one, you can be able to get it. If you are given these ones, P2, V2, T2, T1, V1, and you are asked to find P1, you can as well get it, okay? In any way, you can be able to calculate for what is missing. So we went ahead and looked at an example. If we go to our next slide, you can look at the example we looked at and how we applied the two laws, how we applied the general equation, which is the ideal gas equation, okay? That is the example. We said a certain mass of a gas occupies 146 cubic centimeter at 18 degrees Celsius and 738 millimeter mercury pressure. Calculate its volume at STP. Calculate its volume at STP. We looked at a number of things. We said the ideal gas equation goes with the word STP. Okay? They are mostly common to these ideal gas laws. They are common with standard pressure and temperature. And we said standard pressure and temperature standard pressure and temperature, or standard temperature and pressure, is the same. We have what they call temperature is measured at 0 degrees Celsius, and we say this one is equal to 273.15 kelvins. And we say that for ideal gas equations, we shall be changing the temperature to Kelvin. And we said pressure is 1 atmosphere. And for 1 atmosphere, we said it is equal to 760 millimeter mercury. Okay? We said once they said that at STP, that means temperature is 273, pressure is 760, then what you don't have is the volume. Okay? So this question is giving us the volume, temperature, and pressure for the first part. Remember, you have P1, V1, T2. Okay? Then you have P2, V2, T2. So for this question, we are going to say they have given us the temperature, T1, as 18 degrees Celsius. But we said we have to convert this one to Kelvin. Okay? When we were doing this, we came up with a conclusion that here, this one, in most cases, okay, to O-level work, you round off this one and you find most books having 273 Kelvin. And that's what we would like to use to avoid the decimal places. I know some of you, can be disturbed by these decimal places, okay? So you need to use at least a figure that can help you to calculate very fast, okay? So here we are going to use 273, and we shall be able to get 291 Kelvin, okay? This one, please don't use your head. You can use a calculator. I told you to be with a calculator. Just put this one into a calculator and you get the right answer. Then we look at V1. Is V1 given? Remember, you're saying a certain mass of a gas occupies 146 cubic centimeter. It is 146 cubic centimeter. It is not centimeter cube. It is cubic centimeter. Okay? Then we have been given what? What else? We have P1. They are saying it is 738 millimeter mercury. Okay? That's what they have given us. They have said that calculate the volume at STP. And already we have said that STP, we have temperature, we have pressure. Let's go to V2. We shall say V2, that's what they want. Okay? Then P2 at STP, temperature, we find it at 760 millimeter mercury. Temperature, we find it at 0 degrees Celsius. It is 0 degrees Celsius, which is 273 Kelvin. Okay? So now then this number, we said these things are very easy. Once you have the formula and you are able to interpret the question, okay, this is what you should do first. You interpret the question. You pick out what has been given and you look out for what you need to calculate for. Okay? You realize that V2 is not given. And we say that here, if 5 of these ones are given, you can be able to calculate for the remaining one. Can we substitute and see? If we put in what is here, we say P1 is, you say from the formula, you state that formula there. Then you substitute. You say P1 is 738. V1 is, you say times 146. Divided by T1 is 291. 291. This one will be equal to P2 is here. 760 times V2. V2 is not given, and that's what we are looking for. Divided by T2. T2 is 273. 273. Okay? Once you have this one, the struggle goes to making V2 the subject of the formula. And remember at start I told you these subjects work hand in hand. For you to pass chemistry, you have to be knowing at least a little bit of mathematics. Okay? You have to be knowing English because you have to interpret the questions. You have to apply mathematics. Now here, what we are going to is mathematics, making V to be the subject of the formula. Okay? So you have to be knowing at least all those subjects. You have to be knowing physics because most of the laws are also taught in physics. So you can study the same things in 2 subjects and you'll be able to master them. Okay? So you should be able to understand or even other subjects, not only one subject. Okay? So if we try here to make V2 to be the subject of the formula, what do? We multiply this one this side and we divide this one here. So we say it is going to be 738 times 146 times 273 divided by 291. Since this one is dividing here, we multiply it there. 760. Then we get our V2. Can we now get to our calculators and we put in this? What you do, you open brackets on the calculator, you put 738, you put multiplication sign times 146 times 273. You close the brackets. You divide, you press division sign. Then you also put brackets 291 times 760. You close the brackets and press the answer button. Okay? Can we do that very fast and we'll be able to get the right answer? Okay? This answer should be in centimeter cubed, which is 147. It is 176. Please, if not the right answer, you press the calculator very well. Press it until you get this answer. I remember I told you that during your free time, make sure you play around with the calculator to understand a few things, okay? At least get to discover where the buttons are, so that you don't waste time looking for 7, looking for 3, looking for 9, looking for 1. You just be knowing where the buttons are, and work will be easy. That's all what we looked at yesterday, okay? That's what we looked at yesterday, and we said yesterday's part was measuring on 2 laws. We measured on what they call Charles' law and Boyle's law. And those laws helped us to get what we call the ideal gas equation, okay? So today we want to look at another law and see how it can also be applied. Okay, we have taken much time on this work because yesterday we did one example. So today we had to come up with another example to emphasize the same point, okay? Make sure you know the laws in your head. And getting those laws, it is very easy. You may not know the words, but at least know that Boyle's law, it is V directly proportional to 1 over P. So you can phrase your English there, okay? You know that Charles' law is V directly proportional to T. So what you need to know is the volume of a given mass of a gas. Then the rest you add there, okay? And when it comes to temperature, we talk about absolute temperature. And we say that on when we are using the word absolute temperature, we use what we call absolute temperature scale. And that scale reads the temperature values in Kelvin. So once you have temperature in degrees Celsius, you have to convert them to Kelvin. If you do a number in degrees Celsius, this answer will not be considered, okay? Because now we are looking at the units, okay? So please be able to comply with what you are supposed to do. The only way you can master these things, do very many examples, do the exercise we sent you. Those numbers the slides are already there on our website. We said our website is www.kodaischool.ac.ug. Don't go there and just look for the work. First create the account. After creating the account, you log in, then you'll be able to access all the slides. In case you get any problem with accessing the work, please drop a comment on our top television page, okay? On Facebook, we shall be able to respond to you and help you out. So let us continue with what we are going to aim at achieving today. On our next slide, we can look at what we are going to look at today. Today's subtopic is going to be very small, and that is going to be Gay-Lussac's law, okay? It's a very complicated word. I know some of you are going to face challenges with it, but accept that is the word, and it is going to help us know more concepts in chemistry. What we are looking at is learning the concepts that can help us achieve and be able to proceed with the next step. Remember, the president emphasized studying sciences, so that's why we are here, to make sure that you achieve your dream. We know very many people have dreams in studying sciences, so we are here to make sure that your dream comes true, okay? So we have said that we are going to look at what they call Gay-Lussac's law. And this is going to be our major point of emphasis today. What are we supposed to achieve in today's lesson? Today's lesson, we just need to achieve 2 simple things, okay? Very small chapter for today, but at least make sure you achieve whatever we shall study. Make sure by the time this lesson ends, you are able to describe this law, the Gay-Lussac's law. And make sure you are able to apply it in calculations. Remember, I've always reminded you that this topic is called mole concept, and mole concept is all about determining or calculating the number of particles, okay? So calculations are a must. So when we go to our next slide, we can see we can now start to dig deep to details of this chapter, okay? We see what do they mean by Gay-Lussac's law? On our next slide, we say that this is the third law describing the behavior of gases. Remember, we said that the behavior of gases, when they are exposed to changes in temperature and pressure, they can be summarized in two simple laws, okay? But now, today, we come up with the third law. We said that we can even involve in the third law. Remember, we said the key things in this chapter. We have volume, we have temperature, we have pressure. The first law was varying volume with pressure and keeping temperature constant, okay? The second law was varying volume with temperature and keeping the pressure constant. But today we are looking at it, bring back the slide, we are looking at what they call the Gay-Lussac's law. The Gay-Lussac's law, for it is going to show us that it is going to put the temperature and pressure to be constant, then vary only the volumes. Then let's look at the law. The law states that when the gases react, they do so in volumes which bear a simple ratio to one another and to the volume of the product if gaseous, provided the temperature and pressure remains constant. Provided the pressure and temperature remains constant, okay? That's what we are going to look at, okay? When the gases react, they do so in volumes which bear a simple ratio to one another and to the volume of the product if gaseous, okay? So all the equations we are going to look at now, they are going to be gaseous equations. If we can move to our next slide, we are going to see what they mean in this law, okay? You see that the first equation is showing you that is a gaseous equation. It is hydrogen gas reacting with oxygen gas to give water. And we are saying that for the past days, we have been looking at the first figures to be the moles. Now we are saying, we are calling those first figures to be the volumes. We are saying that now look at that equation, it is balanced. You have to add, you write it like this, gas plus oxygen, gas producing water, gas, okay? Water gas, this is the steam. This is the vapor you see, okay? The vapor it is termed to be in gaseous state, okay? So the two, if you look at them, that oxygen, we have two here. Oxygen, we have two here. Water, we have one. What do? We balance the two. We say we have to put there a 2. We say oxygen, 2 atoms, oxygen, 2 atoms. Hydrogen, there are 4 atoms. Here, how many do we have? We have 2. We put a 2 here. So that the equation balances. Once the equation has balanced, then we can apply our English now. We start describing this equation. We say that now here we are seeing 2 volumes. Can't you see it? There are 2 volumes, okay? 2 volumes of hydrogen. They are reacting with 1 volume of oxygen. 2 volumes of hydrogen. They are reacting with here. We say here is one volume of oxygen. Okay? To produce what? To produce 2 volumes of water. So that's what they are aiming at, that in this Gay-Lussac's law, we are going to be looking at the volumes. If 2 volumes of hydrogen are reacting with 1 volume of oxygen to form 2 volumes of water, that means if we change here, if we increase this number, all those numbers will change. If we decrease this one, all those numbers will change. That means, take an instance that if we put 4 here, okay? If we put 4 on hydrogen atoms plus oxygen, okay? We are getting water, liquid. Here, if we put 4 here, it means that 4 times 2, they will become 8 atoms of hydrogen. And that means here we shall also put a 4 there to get 8 what? Hydrogen atoms. But here we're remaining with it 4 oxygen atoms here too. That means even here we shall increase. Okay? That's what will be happening, that we get an equation and we use it to calculate for what they have asked for. Okay? Then let's go back to our slide and we see that the second equation is saying hydrogen, see it, hydrogen gas plus chlorine gas, we get HCl. Okay? Let's come back to our blackboard now. Hydrogen gas, okay? We add it to chlorine to gas, okay? We shall be able to form HCl gas. The slide there is showing you this, but analyze the equation. Is it balanced? 2 hydrogen atoms, 1 hydrogen atom. 2 chlorine atoms, 1. What do we need to do? We put here a 2, and this equation will balance. That means in description, when we are applying our English, we shall say that 1 volume of hydrogen is reacting with 1 volume of chlorine to give us 2 volumes of HCl. Okay? So we are going to use all this to do a number of things in our calculations. When we go to our slide 12, we shall see the very first example. Okay? We're going to look at the first example and see how we can apply this idea into calculations. Okay? We said this is a topic that is involving calculations. Okay? Whatever we talk about, we have to calculate something. Whatever we talk about, we have to calculate something. And this topic, please take note of it. It comes in objectives, that is paper 1, chemistry, O level. It comes in paper 2, structured and SC part. It comes in paper 3, the practical paper. Number 1, it involves calculations. Okay? After getting those theta values, you see a number of questions requiring you to calculate. Okay? So please, this is a very important topic and you should make sure you pay attention to it and you understand everything. Once you understand everything, you stand a chance of passing all the numbers in exams. Okay? So let us look at our example. Let us remove this one and put our focus on that example. The example is saying 100 cubic centimeter of hydrogen were burnt in excess chlorine. Number 1 is saying 100 cubic centimeter of hydrogen burnt in excess chlorine. Okay? We said before we do anything, we begin with the equation. 100 cubic centimeter of hydrogen were burnt in excess chlorine. It is not where, it is where. So let us look at it. We are saying that the first thing we do is we write the equation. Hydrogen gas, when it reacts with chlorine gas, we get hydrogen chloride gas. Okay? We get hydrogen chloride gas. And we said for you to be safe in this topic, you should be able to balance the equations. We have 2 hydrogen atoms. We have 1. We have 2 chlorine atoms. We should also be with 2 there. So when we put a 2 there, you'll realize that now the equation is balancing. Once the equation balances, what is remaining is you doing the number. We put in now our grammar. Okay? They are saying, the first question is saying, determine the volume of chlorine used. Determine the volume of chlorine used. We have been given the volume of hydrogen. Now they want the volume of hydrogen, of chlorine. Remember we said we first apply our English. We said that 1 volume, okay, it is 1 of hydrogen reacts with, one volume reacts with, how many volumes are there? One volume of chlorine. Okay? One is reacting with one. Okay? So if we say that one mango is put in one bucket, okay, a full bucket is just, you have to put there only one mango. If you put there the second one, it will not fit there. Okay? So if one mango is put in one bucket, okay? Okay, if we say that 1 cup of rice, if you want to cook it, okay, you have to use 1 cup of water. So 1 cup of rice must be combined with 1 cup of water. So that's what is happening here. 1 volume of hydrogen reacts with 1 volume of chlorine. In the question, they have said that 100 cubic centimeter of hydrogen, okay? That means this one reacts with, is there any calculation that we need to do here? We have said 1 cup of rice, you use 1 cup of water. So if you have 100 cups, okay, of rice, how many volumes of water do you need? You also need 100 cubic centimeter of chlorine. It is 1 divided by 1 times 100. It is the same. 1, 1, 2, 2. Okay? 3, 3. 100, 100. And this question will be over. See, we have now started doing the simple questions. Okay? That question will be over. Let's go. That is part A. When you go to part B is saying the volume of gaseous products formed. Okay? Part B is saying the volume of gaseous products formed. C. Is this one gaseous? Yes. And this is the product. How many products are there? Have 1 product, which is hydrogen chloride. Okay? So let us look at part B. If we have this equation, remember, any part you answer, you have to write the equation first, giving 2 HCl gas. Okay? This one reacting with that one to give that one. Okay? So they are saying calculate for the gaseous products. You determine the gaseous products. Okay? So once you have it here, you have the equation. You can see 1 volume is giving 2 volumes of hydrogen chloride. What do? You say, you put in your grammar first. 1 volume of hydrogen produces, okay, 2 volumes of HCl, hydrogen chloride gas. Okay? 1 is giving 2. What about now 100 cubic centimeter of hydrogen produces, that means here, if I say for you to boil 1 cup, when you boil 1 cup of rice, 1 kilogram of rice, you are boiling it, you'll be able to form 2 kilograms of the product of the food. Okay? Rice, prepared rice, it will be 2 kilograms. That means when you prepare it, it increases somehow because there are other things you add that may increase the weight. So from 1, you form 2. Okay? What about when now you boil 100? That means you say if 1 gives 2, that means 100 will give 2 times 100. Okay? Cubic centimeter of HCl. Simple mathematics. Please, I said if you cannot use your head, you use the calculator. You say 2 times 100 in your calculator, you'll be able to get 200 cubic centimeter volume of HCl. Okay? You see, these calculations are very simple. I told you that today we are going to handle a very simple concept. Okay? You can see. It is a matter of identifying the volumes. Okay, you get to know, you read the equation, you balance it, then you'll be able to use your grammar here. You say, if one volume produces 2, now they are saying 100. That means you just put here 100 and you say it will be able to produce what? 2 times 100, and that one is 200, okay? If we move to our next example, we can see a different question, okay? Remember, it is very easy to answer the question, but the hardest part goes to interpreting the question. You must be able to interpret the question. That's why I said this subject cannot stand on its own. There are other subjects that you need to understand to be able to do numbers in this subject, okay? Mole concept does not stand alone, okay? There are other topics also involved. Like in senior 1 and 2, you study about atom, study about formula mass, you study about chemical formulae, you study about balancing the equation. All those things come and help you to understand this topic. This topic is combining a number of concepts from different topics, and even it is combining now a number of concepts from different subjects, okay? So the second question on our next slide, we are saying that 80 cubic centimeter of oxygen are exposed to 80 cubic centimeter of hydrogen, okay? Now they are saying determine the volume of the unused oxygen gas. Okay, now this one is doesn't want you to determine what they use. They have already showed you what they added. So they want you to calculate for what did not react. This one is a bit logical, okay? These ones you have been looking at, they give you something and they ask you it is reacting with what, with how many. Now they have given you the answers. They have said that 80 cubic centimeter of oxygen, okay? They are exposed with, that means they react with, they are put, let me use the word exposed, it is better. Exposed with 80 cubic centimeter of hydrogen. Remember, sometimes when you are cooking food, there are concepts you look at. You say that someone can come and tell you, I prepared rice, but it had a lot of water in it, okay? It was watery. Reason is that you added excess water, and that's what this question is asking for, that you determine the volume of unused gas, that you determine the volume of the excess gas. So in terms of cooking, you say that if someone asks you, I added water, okay, I added 2 cups, but at the end, I saw the food was having a lot of water. It was water, I don't know why, okay? So they will ask you to determine for that water, okay, can you tell us the amount of water that disorganized the food? Okay, because for me, I used 1 cup, and I prepared nice food, okay? So for you, you used 2, and your food was watery. So what is the problem? That's what we want to calculate for. They are saying that 80, they are exposed to 80. But is it true that the whole of this volume will be able to react with that? That's what we are going to calculate for. What we do first is we write the equation. Hydrogen gas reacts with oxygen gas to produce water. Okay? Gas. Remember, we said Gay-Lussac's law only apply to gaseous molecules, gaseous equations. If the equation is involving any other state, what they call Gay-Lussac law will not apply. So one of the principles that you should follow, make sure that the equation is fully in gaseous states. So what we do next is we balance. We said if there are 2 atoms of oxygen there is 1, you put a 2 there. When you put a 2 there, you form 4 atoms of hydrogen. And after forming the four atoms of hydrogen, that means you you'd be able to say these are 4, these are 2. What do? You put a 2 there. And when you put a 2 here, you'll be able to get 4 atoms of hydrogen, 4 atoms of hydrogen, 2 atoms of oxygen, 2 atoms of oxygen. And the equation will be balanced, and you are starting to score the marks, okay? These are the very first marks you score. So after this one, you go ahead to determine, okay? Remember, the question is saying excess oxygen. That means this one is done with the problem, okay? This one is done with the problem, that one is okay. They have not talked about excess hydrogen. That means hydrogen is okay. Now, can we use hydrogen to determine the volume of oxygen that reacted? Because once you get the volume of oxygen that reacted, we shall be able to get the volume of oxygen that did not react. So let us use that idea. We say two volumes. We said this one is grammar. This one is English, it's not chemistry. 2 volumes of hydrogen, okay? Everyone can see them. They are 2. They are reacting with how many? We say reacts with how many? 1 volume of oxygen. 2 volumes of hydrogen reacts with 1 volume of oxygen. That is our stand. Now we said if we have anything like 2 this side on our left-hand side, okay, we should make sure that is 1, okay? Now we shall say 1 volume. 1 volume of hydrogen shall say reacts with 1/2, okay? It is going to be 1/2. If 2 reacts with 1, that means 1 will react with a half volume of oxygen. Are we together here? We are saying that if 2 are reacting with 1, that means 1 will be reacting with a half. That one is simple. Then we go to our question. We said the problem is with hydrogen. Hydrogen, we have 80 cubic centimeter of hydrogen. That means if 1 is reacting with a half, 80 cubic centimeter will react with a half times the 80, okay? That means this is cubic centimeter. And the answer will be 40, because here once, here 4. 40 cubic centimeter of oxygen. Is it the answer that we want? No. This is not our answer. This one is just helping us to get the right answer. We have already got what reacted. They added 80 cubic centimeter of oxygen, okay? They added 80 cubic centimeter of oxygen. Now we want to see the unused gas, okay? Unused gas. How do we get the unused? We get what was added volume minus the volume that reacted, minus volume that reacted. You see, unused gas, you can get the added volume. We subtract the volume that reacted. We shall get what did not react. So what did they add? They added 80 cubic centimeter. What reacted? It is 40 cubic centimeter that reacted. So finally, what is the volume of the unused oxygen? We say 40 cubic centimeter of oxygen. All right? I think this one is a very simple concept. Okay? They exposed the IT with IT. But we are saying that you cannot just add water into food you are preparing, to rice, and you say that you are going to get nice food at the end, okay? Automatically, that water will affect. And that's what we are saying here, that these people adding 8 cubic centimeter of oxygen to 8 cubic centimeter of hydrogen, knowing that volume may vary with another volume. Okay, you might find 3 cups of rice, just to prepare them you use 1 cup. It is not a must that 3 cups you use 3 cups of water. Okay, so if you add 3 to 3, you end up getting watery rice at the end. But we are saying, now after getting the water rice, you go ahead and ask yourself, why did I get the water rice? That means you have to reduce the amount of water. To reduce it, you have to identify first the amount that needs to react fully. That is it. So after discovering that 40 are the ones, 40 cubic centimeter of oxygen is the one which was able to react fully with 80 cubic centimeter. So they are not in the same ratio, okay? It is not 1 to 1, it is 2 to 1, okay? So after discovering that is this one, then you can be able to get the problem, where it came from, the excess. The excess or the unused, you'll be able to calculate for it. You say, if we added 80 and only 40 was able to react, that means 40 cubic centimeter of oxygen remained unreacted. Please, I would like to emphasize a few things to tell you that you need to visit the website, because these are not the only examples. Very many examples are going to be uploaded on our website. Please be able to go there and look at them. If I would ask for the second last slide, we have what we call exercise, okay? Second last slide, we have the exercise, and that is the exercise. You look at the numbers. I've tried to give you the right answers in brackets, okay? So that you use those answers to verify your answers, okay? If your answers are tallying with mine, you give yourself a credit. If they are not tallying, please you try again. If you meet complications, please communicate to us. You can communicate to us through our website, that is www.kodaischool.ac.ug. Or if not, I know most of you are teenagers, and almost all of you are on Facebook. Please go on Facebook on our top television page. You drop a comment there, we shall respond to you, okay, immediately. For those ones who have been texting us very many questions, we have been able to answer them, and I think you are satisfied. If this quarantine time ends and you feel like this content is okay, and you fall in love with it, please make sure you come to Kodai School. This school is found in off Seta Road in a town called Bajo. When you reach there, you ask for Kodai School, and you'll be able to access this work in details. Please remain as Saul Chamanya. Tomorrow shall be handling chemistry A-level. A-level students tomorrow be on. Let us meet tomorrow.